Hello, my name is Rimantas. I'm a relatively young web developer professionally. I spent only about 7 years earning my salary from Perl. Schedule of applications. Essentially, in the previous place I was working on, I was assigned a task to get to solve a very simple problem. So we got a quote engine, and we had to send a reminder email 5 days before that quote expires. Given that quote did not expire, was not processed, or any other conditions were not met, and obviously, when it comes to what scheduling or something to do with time, especially for people from management and from everyone else, comes to mind a thing called cron. And cron, as you can see, is utility for time-based job scheduler in Unix-like systems and whatnot. I threw it out of the window straight away because I did not think it's any use of solving that particular problem in the first place. And the reasons for that are that cron, first of all, is platform dependent. While it's not an issue in my particular case, given we run our system on Unix, yes, we've got cron, but still, that doesn't seem right. So also configuration is done manipulating files, potentially performance and concurrency issues. That means that obviously if you have an application, you don't want to edit your system cron, and if you've got application running on multiple servers, how you would deal with that? It's obviously straight away an issue. As I said, it's not scalable across multiple machines, and essentially it tries to solve a completely different problem. Cron actually tries to solve the problem of running jobs periodically. So every certain amount of time, every 5 minutes, every 5 hours, every day, every week, every month, every year. So no, cron does not work. So I try to get some requirements for what I need for my scheduler application. As a nice to have, yes, it probably would be nice to be also OS agnostic, so it would not depend on a particular platform. It potentially could run on Windows, not only on Linux or macOS or anything else. Also, probably storage agnostic would be good as well, so you wouldn't need to rely on a particular database, you wouldn't need to rely on files, that should be also somehow configurable. Then it should be thread multiprocessing, so you can run multiple processes and it still should do the right thing. Should be scalable, obviously, and should have some flexible behavior, as have some error handling. I don't know how particular error handling will be implemented at various applications, so again, it should be somehow flexible. It potentially should be able to retry jobs, so when job fails, maybe it will retry it. Maybe it will retry it with some kind of delay. Maybe that delay will vary per failure. So maybe first time it will retry after a certain amount of time. Second time it will try after that time multiplied by X time, and so on and so on. So like, for example, SMTP or mail service work. So they do not retry email periodically after like an hour. They first retry, I think it's like a few minutes, another retry is after a longer period of time, subsequent retry is even more longer, and so on until it completely fails. So that would be nice to have as well. And it should be also future-proof, so I don't know what yet I will need to do with it, but I need to have some kind of flexibility to account for things I don't know yet what. So that's probably the most tricky thing to plan ahead, because I don't know what I'm planning for at that point. But again, it's something to keep in mind. So if I manage to solve all these problems in my scheduler, for the script or actual job, I would have single responsibility to do something useful. So in my particular problem, it would need to send a reminder email 5 days before whatever, and that would be it. So scheduler responsibilities in that sense would be to create a new job, schedule somehow, somewhere, run that job or script or whatever it is, track the state of the job is essentially to track to make sure that the job is run only once. It's to solve concurrency issues. Record results mostly for reporting, handle retries somehow, perform callbacks, most likely CDI callbacks to some other system to do some other depending stuff, managing delays between retries, and handle don't know yet what. And it doesn't look right at all, because scheduler does too many things while actual job does not do very much. So for track state, we need to handle that concurrency. Just a few more details on why we need to record the results. So handle retries, as I said, it doesn't seem right because scheduler tries to do too many things at the moment. So I thought, okay, let's get rid of as many things as we can from actual scheduler, and let's see what we can get away with. So I tried to get rid of handle retries, perform callbacks. Doesn't seem again right place to be for that particular task. And manage delays between retries automatically falls over, and handle don't know yet what, it goes away as well. So we left only with quite reasonable amount of responsibilities. Is just schedule a new thing, run that thing, track state, and record results, which seems reasonable and fits into the relatively small list. So, hold on, what about all these retries, delays, callbacks, and all that stuff? S&P. Somebody else's problem. Definitely not share this. In general, it's probably the script or job which is being run should handle these things. So it should handle retries, callbacks, delays, and whatnot. Because scheduler itself probably won't know for every single type of the job how it should handle these kind of scenarios. Because for one kind of job, for example, for the my reminder email, it would need to retry, let's say, 3 times. But what if then we will introduce another job which will again send an email, maybe not for reminder but for a different case, and it will need to do delays, I don't know, maybe daily, or even with the increment delay or whatnot. So obviously it will need to be changed. So if the job itself would handle that, that means that scheduler does not need to know anything about that, and given the job knows what it tries to solve, it's much easier for actual job to implement that functionality. Review the responsibilities of the job is evaluate old state. Is it okay to run something, to do the job it was designed to do? So when scheduler executes the job, first thing it will do, it will try to check, well, is it the world in that state where I still valid, should I still be run? So it needs to do that. Yeah, is it okay to run? Do something useful, obviously that's the main purpose of the job. In my case, is to send an email to a client, and maybe reschedule itself. if it was an error condition, or if it detected that, well, okay, maybe that port was extended, so maybe it's not the right time to send a reminder, it can reschedule itself instead of relying on scheduler doing something clever. And with that in mind, it can also calculate the delay for retries, do callbacks, alerts, reports, or whatever it needs to do, and do whatever else required, future-proofing or doing something, I don't know yet what. This is very symbolic job example, how it might look in the real world, and very similar to that, I've implemented. It's a bit not fitting into the screen, I wonder. Good.
No, it won't. It's to
right.
do with the. We can look about
right.
stuff.
Anyway, you probably can guess what it says. It's not much there. So there's declaration and the method name, which you can't see here. It's essentially a single method I introduced, like common method for all jobs, which is called surprise surprise run. Then it tries to call self init handles. That's due to the fact that the actual job will be run at some point in the future. So we can't have like open handles in the job. So we can't have database handles or file handles in the job, because they probably will be invalid at the time. So we need to initialize these handles on the runtime. Then we need to call self-remind if it still needs reminding, so essentially we evaluating whole state here, and if we have not got anything back from the result, we will schedule a retry and will perform callbacks and whatnot. So that would be a very simple job example. And scheduler example, on other hand, is quite simple as well. So what you can't see here is that this method is add job and this method is run pending. I did not provide any implementation of that, but essentially add job, what it does, it uses storable freeze and thaw. It essentially freezes the object, pass to it, and get pending will find pending job on the date or date time, and will return unserialized data structure back. And another method in the scheduler would be that it would be able to run pending job. So essentially, it would try to find that pending job. It will try to get pending, and it would try to run that job. Essentially, it would set job status to running to avoid concurrency. Then it would try to run the job and set the job to finish. This bit here is in a try-catch block, just in case it fails over, then it would set job status error. And its recursive function, it essentially would call itself to run another pending job in the queue. And it was working very fine with my unit tests. However, it was failing in the real world, because when you retrieve frozen job from the database or file system or whatnot, it will provide you only with the cache reference, which what storable is designed to do. And you need to load the class definition directly from the class definition. So I probably lost a couple hours debugging that issue, and this is one of the caveats you need to have in mind if you would do something similar. So I modified the previous example just to check for the if the actual job is blessed hash reference, and then I evaluated require class just to load the symbol definitions and methods. And after that, it started working. So that was my approach to the scheduler and how it can be done. I deliberately did not put any implementation with regards to the how the actual jobs would be stored, because that's again up to the user to store it in the database, to in the file system or whenever you like, and to deal with that. So yeah, thank you for listening. Any questions?
Raise conditions in the queue.
Sorry?
With the implementation of the scheduler is shown, you look if there's a job in the queue,
Yeah.
then you change the state,
Yeah.
then you do something.
Yes.
If the thing is running across multiple machines on the same database, there's a raise condition where two machines get the same job.
Yes. You could do that with transactions, and you could do that update on certain condition where if it's not running or something like that.
How do you schedule the scheduler?
You probably well, the scheduler is not something you probably.
No, not
Yes,
asking
you could run that. But probably that would be more serious risk condition at that point.
Yeah.
Thanks, Rimantas.